Hello, my fellow scientists. Welcome to another episode of Science is Everywhere, the home edition. My name is Marie Lenka, and I'm with the Children's Discovery Museum of San Jose. And today, if you didn't know, which you might, is Earth Day. Very excited about that. So what is Earth Day about? We'll get into that and then we'll talk about our experiment. So Earth Day is a celebration of the planet that we live on, and it's a good day to think about just the different things that go on this planet, the natural occurrences, as well as maybe some impacts or things that humans are doing that make a difference to the planet. So today we are going to be talking about, it could be natural, it could be human form, erosion. So what is erosion? Let's talk about that really quickly before we get into the experiment. Erosion is the wear down of the Earth's surface. So like the ground that's underneath you. Now the surface can also be something very small, like sand or rock or mud, but it's basically what the Earth is made out of, the crust that we're walking around and traveling on all the time. And like I'd already mentioned, many things are naturally occurring. So they happen in nature, has nothing to do with what human beings are doing. There are other things that humans are doing that also cause erosion. So today we're going to be focusing on the natural end of things. We might touch a little bit on what human beings are doing in order to impact erosion in the Earth's surface, but we want to make sure that we start with the natural, just because this is a celebration today of the natural world. We're very happy that we have our planet. We're very fortunate. This planet is very, very rare. All right, so what you are going to need for this experiment when we get into it is you're going to need, let's just go down the line. First, 3 different types of, believe it or not, candy. Now, fellow scientists, if you're like me, one of the hardest parts of this experiment is making sure that you don't eat any of your results. So this is for experimenting today. The eating part, maybe you'll do another time. So we chose M&Ms and Snickers and Twix. So those are our different pieces of candy that we're going to be using. You're also going to need 2 different plates, and you'll need what's called a colander. And if you've never seen one of these before, it's basically like a metal or a plastic net that looks like a bowl. And this is going to work because we're going to be pouring things into that, and we want to make sure that we catch the solid material. Now I have a bowl here because I'm going to be doing this out of the sink, but you can actually just put this in the sink as well. So when you drain the water out, it just goes right down the sink. And then you're also going to need, very important, couple of different jars with lids that match. Make sure that they match. This experiment won't go well if they're loose. So 2 identical ones, there we go. They can be glass or plastic. I always like to use plastic, but this is another way that you can go through maybe some materials you have at home and see what could work. You may have baby jars. You may have pasta jars. This, believe it or not, came from dehydrated peanut butter. So that's why they're plastic. But you're going to want 2 of those. And you'll notice I put lines on here at the same height. And you'll see why I did that in a few minutes. We want to make sure that our experiment is the same on both sides. So, all right, let's really quick talk about maybe what erosion looks like. And I'm going to use a kitchen example because, you know, we're inside, we're staying safe, sheltering in place. So I'm going to switch over to this lovely little webcam, and then we'll check out what erosion might look like. All right, so I have made, using just a glass tray here, as well as some of that dehydrated peanut butter we were talking about. This is a pretend landscape. So let's pretend this is a hill. Okay. So talking about erosion, we covered already that it is the wear down of the surface. So what different things can wear down the surface of the Earth? Okay, let's think along natural lines really quick. One of the first things you think of a day where there's lots of clouds, kind of dark. There may be something falling from the sky. What is that? It may be rain, right? Could be snow as well. or could be hail. It just depends on the weather that day. So we're going to pretend that we have a little bit of rain falling first, and that can wear down the earth by kind of moving some of the soil. So what I'm going to do here is I'm just going to pick up a little bit of water, and we'll show you another day on how to use straw like a pipette. But if you take a look here, if I drop a couple of drops, most of it stayed up there, right? A little bit of rain, it's able to absorb. Okay, so we're not really eroding yet. Okay, but what happens if we get a lot of rain? Some of you may remember we had some really big storms here in California in the winter time, which was great. We needed the water. But if you were in the mountains or somewhere where this natural layer may look something like this, something else happened. So I'm going to pretend that I am a huge rain cloud coming along, and here comes a whole lot of rain. Let's see what happens. Oh, what's happening to that layer? It's eroding. It's washing away down this hill here. Okay, so that's an example, very simple one, on how erosion might work with different natural elements. This one particularly rain. Okay, so now what about that experiment I keep talking about? Because, okay, we now know what erosion kind of maybe looks like. Now, how do we mock this up at home? How do we do it ourselves? Okay, so let's get down to that fun part. Okay, so here is all of the materials, or here are all the materials laid out. And I apologize, they're a little bit cramped, but hopefully you can kind of tell everything. All right, so let's go through. So we've got our plates, got a colander in a bowl, we've got our candy, and I'll explain why they're split up in just a second, and our 2 jars with our lines to show how much water we want to put in each of them. Okay, so there are 3 different steps to each of these different candies that we're going to go through. So we're going to make sure that we identify them first. We're going to kind of go through and just experiment with them a little bit with our fingers, tactile version. And then we're going to use these 2 to do our different experiment with the other 2 pieces. Now, if you have 3 different pieces of candy, that works best. We were kind of running out, so I cut mine into 3 different pieces. So I know that I've got 3 identical types of materials. If you've got 3 of the fun size Snickers, that's actually works a little bit better. Same with the Twix and the M&Ms, you get a bunch in a package. So that works out really well. All right, so first thing we're gonna do is we're gonna go through for each of these and feel their texture and see what exactly, when we do this, what does it remind us of? So what different types of maybe the Earth's crust does it remind you of? So let's go for the Snickers first. And this is one of the most fun parts of this experiment. So you're gonna take this and you're gonna squish it. And I know that may seem a little weird. I'm gonna do it over my hand like this so I don't get on the plates and see, okay, now without looking, and you can look too, it's not like it's a secret, it kind of feels like the peanuts are a little bit of the rock maybe, and then there's some mud in there by way of the, that's caramel in there. So that's kind of what it feels like to me when I'm squishing it around in my hand. Okay, so there's that, and I'm gonna go ahead and get rid of that in the sink. This is the hard part, when you get things on your hands and it's like, ooh, that may be good to eat. And we can't do that today. All right, so then going for the Twix, I'm gonna do the same thing. Grab a piece, and actually let's do this. If I end up making a mess, it's okay. I'm gonna squish that too. Ooh, okay, so I'm feeling more of that mud, but there's also some, feels like sand in there. Because it's not rock, it's breaking up. There could be sandstone too, but that's kind of what that reminds me of. Maybe kind of a dry beach with a little bit of mud. I don't know if you guys have ever been like in a sandbox sometimes. You dig so far down and you hit mud under the sand. Almost feels like that too. Okay. And the last one, the M&Ms. And see, I'm already making a mess. That's half the fun. Go ahead and feel that. Oh, wow. Ooh, that's tough. Okay, that reminds me of just stone. That's seriously rough. If you can squeeze one of these flat, I'm impressed. Now, if you got Skittles, they may squish a little bit more, but what do those feel like? What do those remind you of? Okay, it didn't change all that much. All right, wash off the hands. So now that I've got kind of an idea of what the different textures are like, now I'm going to do my experiment, kind of keeping in my head what this could possibly be if this was the Earth's crust. So that mud, that rock, that sand, all those different types of things. Okay, now I have two different plates. And the reason I have two different plates and actually two different sections left over of everything is one I'm just going to set in standing water, and one I'm going to set in water that I'm going to shake up and really see what happens. So what does standing water mean? Can you guys think of, if you're standing, what are you doing or not doing? So usually you're not moving, right? Okay, so standing water is not moving. And we talked about how moving water, like what you saw in the landmass, moves along different parts of the earth. Okay, well, if it's just sitting there, is it going to do anything? All right, so let's try this. So you may be able to see here, I've already filled this up, and unfortunately, because it's sideways, I can't actually use the line to show you, but each of these are filled up to that line. So what I'm going to do is I'm going to put one Snickers in there and one Snickers in here. All right, seal that up. That one's not going to move, not going anywhere. All right, this one, make sure that lid's on super good, because now what we're going to do is we're going to shake it up. You guys ready? Shake it up for a minute. Keep shaking, keep shaking. If you want to do this, you can. If you notice a little water coming out, you might want to stop for a second and make sure that that lid's really on, really good. Shake it. So this could be ocean waves. This could be different types of hard rain. This could be water flow, like a river, something like that. All that going on. Keep on going, shaking, shaking. Okay. So now if you see, things are kind of swirling around, and it's in there, but let's see if I can get that a little bit closer. Seems a little, like, kind of cloudy, right? And there's stuff on the bottom, which is kind of hard to see, but here's how we're going to see it a little bit better. First of all, we've got our colander in our bowl, and I'm going to label these before I even dump anything. This is my water. This is my standing water that's not going anywhere. And this is my shake erosion. Okay, so shake erosion, do it one more time for good luck. Okay, so go ahead and open up. Actually, you know what? Let's open up our standing first. You're gonna pour it out into the sink, into your colander. And check it out. See what that looks like. Let me try and get that a little bit closer to the camera so you can see. It looks pretty much the same as when it went in. Not a whole lot of change. Put that there. Okay. I'm going to dump out my colander and my bowl. There we go. All right, I'm going to open. This is the shake one. This is the one that I really messed with. Ooh, I don't know if you guys can see that, but take a look at yours. You'll be able to see it a little bit closer. With mine, I can see there's little particles in there. So it kind of broke up, not a whole lot, but you see there are some little pieces in here, and you may be able to see that a whole lot better with yours. So I'm going to take that out, and you can see also it's kind of rounded off the edges a little bit. So again, not a whole lot of change. If I did this for 3 minutes, I'm going to get those little particles out of there too. which is what we recommend. I may see some more change, but you can also see like on the inside, it's starting to get into where that nougat was, where that caramel was that we kind of thought was a little bit muddish. You can see a little bit left over in the bottom too. And again, take a look at yours. You're going to be able to see yours a little bit better because it's closer. Dump this out. We're going to repeat the same experiment with our Twix bars. Okay, I'm going to fill up my containers. And while I'm doing this, go ahead and fill up yours as well. So we're doing this together. And if you have a little leftovers from your last experiment, what I would recommend is to rinse this out so you get all the little pieces out of there before you try your next one. Okay, everybody measuring out their water? Go ahead and put these back. And it's a little wet on the outside because it was just in the sink, so I'm going to tap this down, make sure that I don't splash myself. Splashes happen. Welcome to science. All right, everybody ready? So I'm going to take my Twix bars now. And like we talked about before, you may have a different type of candy that you're using. That's okay. I'm going to take one of these, put it in my standing water. Take another one, put it in my shake water. Okay, standing water sealed off. Shake water sealed off. Make sure that one's really good. Okay, you guys ready? You have your candy in? Pick up your shake water. Again, make sure that's pretty tight. And we're going to shake for about a minute. Here we go. Shake it, shake it, shake it. And if you've got some really good music, now's a great time to use it. Take it around like this. You can switch hands. And it's kind of funny while you're doing this, if you try to talk, it sounds like you're bopping around. Have fun with it. Keep shaking, keep shaking. You can see that flying around in there. Can you see yours flying around in yours too? A little bit more, we're almost there. Okay, I'm gonna go ahead and stop. And I can see it's swirling around. Oh, did you see that big chunk go by? Take a look at yours too. See, is it together still? This was the one that kind of felt, at least to me, when I felt the Twix bar, felt like some mud, maybe a little bit of sand. You may feel something different in yours. All right, so here is my standing water. Dump that out. And taking a look. Go ahead and take a look at your standing water one. Did it change much? At least the Twix didn't. So there wasn't enough time for that water to actually absorb in, and it didn't erode. So there's just the standing water. Dump this out. And if you guys are using the sink, this may work a whole lot better for you. You're not going to be going back and forth in a kitchen like I'm doing. All right. Here's my shake water. Pour that out. Ooh, lots of little bits in there. If you take a look, pull this out, I see a whole bunch of little chunks there. Ooh, if I do that, that makes it even more obvious. And that looks like the little pieces of kind of the cookie in there, which I felt like was a little bit of sand. And if I tip this up like that, oh wow, you can really see. See how that eroded in there? Hold it up over a plate so you can see a little bit better. It really took a chunk out of that. And again, those sides are getting worn down as well, which you may, again, see with yours. I'm gonna stick that there. All the little pieces, I don't know if I'll be able to get them out. All right, so, and I can see it in the water too. See them floating around? All right, which you may see in yours as well. If your colander can't catch the little pieces, it'll actually end up in the water below. All right. Wash that colander out to make sure that I don't have those little bits and pieces for this last experiment. Okay. And while I'm filling mine and getting ready, check out yours. Okay. Last, but certainly not least, I'm gonna try our M&M, which I felt like was kind of a stone. Let's see what happens. Again, I'm gonna rinse this one out. This is my shaking one, which may still have some pieces. Okay, go. And drop one in the standing water, close it up. One in the shake water, close it up. All right, here we go. 1 minute. Do you have your candy in? You ready? Shake it up. Oh my goodness, I can see something happening right now. There's a new light. Keep on shaking, 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 shaking. Okay, almost there, almost there. I gotta switch hands. All right. Whew. My hands are tired. Okay, so let's look at our standing one first. You can see from the top, and I probably should have done this to start. Pour that out. Come out of there. Okay, still looks pretty much the same. Just fish that out. There's a little erosion, but not much. You may be able to see a little blue around on my hand. But that pretty much stayed the same. Oh, there's the blue. Now on the other one, let's do that. Let's check out, see what happened here. Pour this out real fast. Okay, here we go. Oh my goodness, what happened? Can you guys see that? There is no more blue left on this at all. The erosion was major. So we can see even for stone, water is strong enough to erode, to wear down the outside of it. Well, stone in this case being an M&M. But you can definitely try this with natural materials as well. We did candy just because it's fun. You can go out and get different rocks out of your yard, things like that. You want to use a little bit of potting soil, you can try that. Again, we use candy just because it's fun. So take a look at yours, and I would love to see what types of candy you used. So if you want to go ahead and take photos and let us know what worked, what didn't, and what you observed, what you saw, we would love to hear about that. Okay, so let's do a quick review on how this experiment went. All right, my fellow scientists, so let's review. How did we do this erosion experiment? First of all, we took our candy and we did a texture check, which means that we felt it, we kind of squished it around. What does it feel like? What kind of, maybe materials on the Earth's crust did it remind us of? After that, we filled the jars with water, making sure that it went to the line, and also making sure that the lid's on the top. And we went ahead and put our candy inside. So actually that's something that should be right here. So fill jars and add candy. Okay, so we're gonna fill jars with water and add the candy in there. Then after that, we went ahead and shake them up, seal them up, and shake up one of them. See what happens. Okay, that'll take about 1 minute to 3 minutes. Again, we only did about 1 minute, but you can go up to 3. And last but certainly not least, pour out and look, check it out. What does it look like now? Question that somebody had, can you get in there and feel it again? Absolutely, yeah, check it out. See if it's maybe softer, maybe it's the same texture. Again, this is just seeing how the wear happened, how the wear down, how it actually broke down, if it broke down. Because like we saw with the M&M, there's a little bit, but it was still pretty solid other than the fact that, the outside was gone. So again, this is our Earth Day activity for Science is Everywhere, the home edition. Thank you so much for tuning in. We're bringing content via the Children's Discovery Museum to everyone who is at home right now and hopefully having some fun at the same time. Feel free to jump on our website, www.cdm.org, to both sign up to know when these new pieces of content are coming out, as well as maybe how you can help. Because we are bringing this content for free, but we're always appreciative of donations, and every little bit counts. Never think that, oh, well, I can't do that much, so it doesn't matter. Everybody's does matter. We're all pulling together right now. So thank you again for your time, and we will see you at our next broadcast of Science is Everywhere. Thank you again, everybody.